Welcome back to the TrueGrid tutorial series. In this video, we are going to show you another example of the projection method. This time we will project to a surface that we will import using the element and coordinate files for an automobile model. We are going to build a single block mesh and position that mesh before we project it on the surface of the auto hood. We call this initialization of the part when we are moving and adjusting it into the best location before projection. Then we will examine the initial projection and look for quality issues to show you how to solve these issues to improve the quality of your mesh. We are going to add a 2D curve and combine and attach two edges to that curve. We are going to insert partitions to give us a 3-block mesh. We are going to label and move nodes into new positions, and we are going to add a 3D spline curve to an edge. We strongly suggest that you follow along with an active session of TrueGrid running in another window. From time to time, you may want to pause this lesson and replicate what we've just done in your live session of TrueGrid. If you don't already have TrueGrid, please visit our website and request a 60-day free trial.
I'm going to import geometry into TrueGrid. So this first file that I'm going to use is basically nodes with X, Y, and Z coordinates. And these are the node numbers. And this file has about 10,000 points. Now the second file is connectivity, like as if it were finite elements. And it has polygon names. For instance, the first polygon is a polygon called hood. And these are the 4 nodes that form that polygon. Then we've got body, and that's the 4 nodes that form the body. Now there can be many polygons that have the same name. So all of the hood polygons will be grouped together as one surface, and the bumper another one, the body another, and so on. And when you see an example of a polygon that has more than 4 nodes, what TrueGrid does is breaks that up into 2 polygons. The assumption is that when there's more than 4 nodes, it's planar. So there's no ambiguity as to how to break that up into smaller polygons. So I'll import this. It's known as a 73 sbug_h. Both in the coordinates and the elements. I'm going to go into the merge phase. It gives us a window now, so we can look at geometry when we import it. And I'll go to the CAD menu and use the VPSD command. This imports polygon data. This was used primarily in the biomechanical professions. So we'll tell it to start numbering surfaces at 1, and we want the nodal first, so that was 73 sbug_h dot cor. And then the polygon connectivity was called 73 sbug_h dot ele. One might wonder whether it's a finite element model already, but it's not. The polygons are not designed to do any justice to a finite element code. So it found 15 surfaces. And remember, we're looking at those polygons called hood, and they formed this set right here. Now, there are multiple surfaces here that we should point out. I'll label them. That's a little hard to see. That's better. And if I pick, for instance, surface 1, it highlights the hood. Now, in TrueGrid, surfaces can be quite general in their nature. For example, surface number 2 has a bunch of holes in it. Not a problem for TrueGrid. Projection works just fine. Or we could look at surface number 3. It's 2 surfaces that are separated, but as far as TrueGrid is concerned, projection works just fine. Now, what I'm going to do is demonstrate to you how to use a polygon surface like one of these to build a mesh. And I'm going to take the easiest one, surface number 1. And I'll have it show only that one surface. Now I've shown you methods already on how to start building a mesh and projecting it to a surface. I'm going to show you another one. I'm going to put a shell mesh onto here. Now, shell elements are constant in one direction. When we built a part before, we would have 3 lists of coordinates. Let's go to that. We use the block command. And before, we would put a list in all 3 directions. But now we're going to have one of the 3 directions a constant. So I'm going to have it build us a mesh, a block structure, a single block structure from 1 to 11 in the I direction, and from 1 to 11 in the J, but a -1 in the K. In other words, it's a constant K. Now for coordinates, well, I could figure some things out. There are many ways that I can glean coordinates off of this, but I'm going to try another technique, just so you see a variety of techniques. So I'm going to give it 0, 0 for the 2x coordinates that correspond to the 2 I indices. And I'll do the same in the j direction for the y coordinates, 0, 0. And then finally a 0 for the z coordinate. So basically what I've done is I have collapsed all of this mesh, these 121 nodes, all onto the origin, all collapsed to 0. Now what I'm going to do next is I'm going to move it close to this surface by going to Move Points, selecting everything, and click and drag to here. So here's where it sits right now, this collapsed mesh. I'm going to put it right in the middle here. Now the next thing I want to do is to move this edge, it's highlighted in blue, and move it over to here. Just that edge. But there is a straight line. I'll move this edge, the opposite edge, over to here. Well, it's starting to show up in the picture. Let's move this edge over to here. And this last edge right to here. Well, that's not too good yet. Let's make another move here just to get it closer. I'll move the whole thing in this direction to there. Now we're getting closer. Now the next step might be to project this face of our mesh onto this surface. And what it's going to do for every node is to move it to the closest point on that surface. I'll pick the surface and project. Now what it did not do is to place every edge along the edge of the surface. We have to take the steps to do that ourselves. It gives us full control, but it requires a little more effort. But it's surprising how little effort it's going to take to get it to do what we want it to do. So for example, I could grab this vertex and move it over to here. And it snaps back to that corner of the surface. The same is true here. Now there's a little more work needed up here. If you look at the polygons that form the surface, it's not symmetric down this line here. And the best way to emphasize that would be to describe how TrueGrid finds corners in the surface. This is considered a corner because 2 of the edges of one single polygon are on the boundary. That is not a corner. That might be hard to see. I'll zoom in here. This is a corner. This is not, because only one edge of this polygon is on the boundary. This polygon has only one edge. This polygon has only one edge on the boundary. But that is a corner. Now we come over here, and you'll see that it's different. We have a corner here, and we have a corner here. Now, why is that important? Well, TrueGrid automatically calculates the boundary edges of a polygon surface. And we're going to label those surface edges. And here's where this unusual nature of this surface shows the value of this method. If we were to click on this label here, you'll see that we have an edge of our surface that starts at this corner and ends at this corner. Another edge of our surface, second one, the one that's labeled 1.2, starts here and ends here. Those are both corners. The point being that TrueGrid finds the connections between corners and calls it an edge of the surface. The reason that's important is because we would like to attach this edge of our mesh to this edge of the surface, only it's not one edge, it's two. So we need to combine these two into one. So we go to 3D curves. We click on the curve command. We'll give it a number, curve number 1, and we're going to use an edge of a surface to start with. Now I need to select, by picking a label, this edge right here. And then I hit the F8 function key, and it types the edge identifier into the command. And then I will append it to that a second edge of a surface, this one here, the function key F8, execute and quit. And now, instead of having two edges, I'll label the curve. We have one curve. So then we can select this edge from here to here of our mesh, and we can pick the curve. Instead of a surface, we pick a curve and attach. And now we've got our mesh following the boundary of the surface while being projected to that surface. It's not very good. For example, you'll notice here, well, why is that happening? Well, the features of this surface are smaller than our elements. And as a consequence, we're losing some of the detail. Well, that's one of the reasons why a single block doesn't work. You have to have more detail in your block structure to capture the features you want. And what I want to do is to be able to move this vertex right there, but it's not a partition. So I will make it a partition. This is known as inserting a partition. I want to make sure I have the right edge. This is down here, so this is in the I direction. So I'm going to add a partition in the I direction, one element from the beginning. It's a regular partition in the I direction on the right-hand side of partition 1, one element in. Oops, I made a mistake. I put it over on this side instead of here. So now I want to put one over here as well. So we'll do another one. Insert partition, regular, in the I direction on the left-hand side. On the left-hand side of 3. Index 3, one element in. So now I have my two partitions that have been added to this part. So I have a 3-block part now. But now this node hasn't been moved. We need to position it right here. because its initial position projected it to this surface and it landed right here. We need to change its initial position. I want to move this vertex to that location right there. So I'm going to label the points on this surface. Now, sometimes you don't get everything labeled. TrueGrid will not put two labels in the same or similar, almost the same location. So when that happens, what you should do is zoom in a little bit. Now it's labeled. Now I want to select this vertex. Right here and move it to this point. So I will pick this labeled point and attach. Well, things look strange now. I'll turn off the labels. What has happened is a natural result of the projection method. And I'm going to demonstrate that by turning off the projection so you can see what the algorithm sees before the projection is done. So I'll go back to the history table of all of the commands that have been issued and turn off the projection command, just temporarily. Now here's the problem. The way we built this edge goes the way you see it here. This is that new edge that we inserted. And it projects nicely up here, but down here, the closest point is the boundary. So it's not doing anything that's appealing to us. I'll turn on the projection again so we see the end result. We're going to have to do something about this. But before we do, let's make sure that this vertex down here is at this little divot. I think this is for the headlight. So I'll frame in and I will take what I want is that vertex right there. And I want to place it right here. So I will once again label the surface points, pick that point and attach to it. Now we're getting a warning telling us that mathematically it cannot find the ideal way of distributing these points. That's okay. This is just a demonstration anyways. There are things you could do to change that by adding more elements, for example, but I don't want to go to that trouble. So how do we fix this? Well, we create a 3D curve and attach this edge of the mesh to that 3D curve. It's not hard to do it all in TrueGrid. So I'll go to the main menu, 3D curves. We're going to create a spline curve. And we're going to do it by selecting some points on the surface. We can get rid of the labels now. So I'm going to tell it to project to the surface. Pick points by projecting to the surface. And I'll start with, well, actually, I don't want to start there. Let's start with a node first. We're going to have a node here, or a point here, and a point here. And all of the rest are going to be projections onto the surface. So we'll put a point, let's say, right here, 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 and here. And we will call that curve number 2. And then we can attach this edge of our mesh to this curve right here. So what it's going to do is it's going to attach this edge of the mesh to this curve and then reproject it. And we get a perfect solution here. And we can do the same on the other side.
I have a question. So why do we
put -1 for the k index? Is that so that we're gathering in the third dimension? Do I understand this correctly?
Yes.
Does it have to be k?
I could have done it with I or J. And then you'll see that in more complicated problems, we can do it in 2 directions or 3 directions.